Okay, so now that we know a little bit about sequences, we can see what they have to do with our functions or our graphs, algebra, etc. You do not need to write this screen down. This is where we're going to compare arithmetic sequences, which are linear functions, with our geometric sequences, which is the next slide, which you do need to write down. So again, you do not need to write this down, but you do need to remember that arithmetic sequences are our linear functions. So we spent most of first semester talking about linear functions, y equals mx plus b, graphing straight lines, and all that time they were arithmetic sequences. We just didn't call them that, okay? But remember that they have a starting value, that's our b, really, right? Remember our number outside all by itself. And they have a common difference, which has a fancy name that we call the slope, which in this case would be 2, and that's how we knew it was a positive slope. Now, this slide you absolutely must write down. My advice is to pause right now, write it all down, and then pick up so you can make notes about what I'm saying as you go. So geometric sequences are exponential functions. We are no longer dealing with straight lines. Now our lines have a curve to them. And they have their own special equation. Remember we had y equals mx plus b? Well, now we've got y equals a times b to the power of x. This x is an exponent, so it's b to the power of x, okay? So one of the trickiest things you're going to have to do is figure out on your phone calculator how to put in exponents, okay? But I will attempt to help you with that in class. Somebody might need to remind me, though. So geometric sequences, they have a starting value, that's our a. Our starting value is a. Let me do that different color. Our starting value is a. Our common ratio, remember whatever we're multiplying or dividing by, that's our b. And then the x is a number that goes with the y. It's a point, the point xy, that we could put in and find some points, okay? Don't worry, we're going to figure all this out together. These graphs have curved lines, and you'll notice there's always a point that they never go below. For us, that is going to be 0. They're never going to be negative. They're always going to get as really close to the x-axis, but never quite there, okay? And that's called the end point. That is not right. That's not what that's called. End behavior, that's what that's called. So this is the formula, the equation that you need to be thinking of for this chapter, okay? So you'll notice here we have an equation, y equals 2 to the power of x, which means our a is 1 because there's no other number being multiplied there, so our a is 1, which will happen quite a bit. And in order to graph these, which is what we're doing, you need to make a table. Okay. So here, let's do some examples. Actually, we're not graphing until next week. This week, we are just figuring out if a number works. I totally just lied. I am so sorry. We are totally graphing. I am so confused. I'm sorry. We are totally graphing. So let's do some examples. So remember that the a is our initial value or our y-intercept. Okay, so in this case, a is our 2. Our b is our common ratio, factor of change, I also most often call it the multiplier, okay, because we're multiplying or dividing, but really when we're dividing, we're multiplying by a fraction. So we're multiplying. So, and that in this case is our 3. So how do we do this? Well, we pick some x's. For right now, we're going to pick the x's, -2, -1, 0, 1, and 2. We're going to put that x in for our exponent, okay? So what that means is that I don't have enough room, but we're going to do y equals 2 times 3 to the x power. In this case, we're going to take it to the -2 power, okay? And again, in class, I will show you how to do that on your calculator on your phone. But for right now, I'm just going to do it for you on my calculator. So 3 to the power of -2 times 2. And you'll notice we're going to get a lot of decimals. Okay, so really what I should have written in here is y equals 2 times 3 to the -2 power. And y then equals 0.22. We're going to get decimals, just round, it's okay. And then we're going to do the same thing, y equals 2 times 3 to the -1, because that's the x that we're picking. And so we're going to do 3 to the power of -1 times 2, and that equals 0.67. And we're going to do it again, y equals 2 times 3 to the power of 0, and that equals 2. And then y equals 2 times 3 to the power of 1, and that equals 6. Y equals 2 times 3 to the power of 2, and that equals 18. So now you have a table. Now you have points. You have the points, -2.22, -1.67, 0, 2, my brain was getting ahead of me, 1, 6, and 2, 18. Oftentimes, there is a point that you have figured out that's not going to fit on your graph, and that's okay. And also, I don't have enough. This isn't a very good graph for this, I'm sorry. So I'm going to make myself another whole line there. And we're going to do -2, so over 1, 2, and up 0.22. 0.22, that's less than a fourth. So that is not very much. Actually, I'm going to do this in green. Not very much at all. Okay? And then I'm going to do -1.67. 0.67, that's more than half, not quite 1. It's actually 2/3. So we're going to put it there. Your points aren't going to be exact at this point when you're doing decimals, but they need to be about where they belong. And then 0, 2, 1, 6, 2, 3, 4, 5, 6. And then the 2, 18 isn't going to fit, but we know it's going to be like way up at the top there. And so then you'll see we have a curve. Notice that our curve is never going to hit 0. So be careful when you're drawing your line that you make it not go below. You don't want to do that. It's never going to get below 0. Okay? And that it curves. So if you end up with a straight line, you did something wrong. Okay. Notice that it's curving up to the right. This is growth. Okay? We will also have decay. I'll show you some examples of that. Maybe. Okay, so let's notice that it already gives us our x's, okay, but we're always going to use those same x's for right now. Technically, we might need to use more, but for what we're doing, you and me, that's going to be good, okay, for right now. So we're going to put into our formula here 2 times 4 to the -2, and that's going to give us our y. So this table is just missing this middle piece. You don't have to have to write that in your table, but I do need to see this work that you have, even though you're just putting it into a oops, I don't know why I changed the number, calculator, you still need to have it written out that that's what you put into the calculator, okay? Okay, and to save time, I already have some answers, so we've got 0.125, 0.5, 2, 8, and 16. Nope, I lied. 32. And when we graph that, so that means we've got -2 and 0.125. I mean, that's going to be barely over the line there. And then -1, 0.5, which is half, so halfway or so. 0, 2. Again, we're not going to be on those decimal ones. I'm not going to be picky as long as they're not, you know, way off and up here or something. Okay. And then 1, 8, and then that last one isn't going to fit on there, but we know it's going to be way up there somewhere. And notice down here, I'm not having my line go below 0. Okay. Do not forget that you have these two questions. Okay. You need to make sure that you know, looking at the equation, what's the y-intercept and what's the multiplier. Okay. The y-intercept is your a, right? And your multiplier is your b, which in this case is 4. So again, we have, this is growth because it's going up to the right, okay? And then we have a different kind of example here about growth. Well, we know it's growth because in our table, our numbers are getting bigger as they go down. So we know that that's growth, okay? So notice now we have a filled-in table, and we want to know, excuse me, what's the growth factor, what's the initial value, and then what would the equation be, okay? Well, notice here we have growth. Our numbers are going up, right? Okay, and remember that our initial value or our y-intercept is a. It's that number, right? Well, when we look in the table, the number that's with our 0, our x is 0, that's our y-intercept. So over here, our initial value or y-intercept or b, or a, would be the 3 because it's with the 0, where x is 0, okay? Our growth factor, and just so you know, it's called a growth factor or a multiplier, whether it's going up or going down, okay, is we need to figure out what are things being multiplied by. Well, it should be multiplied by the same thing each time, right? And I don't know about you, but when I look at those decimals, I'm like, I have no idea. But I know that 3 times 7 is 21. And if I put in my calculator that 21 times 7, I get 147. Double check just to make sure and do one of the decimals. So like put in 0.061 times 7. Do you get 0.429 or so? There's probably some rounding in there, so maybe not. But our growth factor then is 7 because that's what I'm multiplying by every time. We multiplied by 7 to get each thing. Okay? And now, remember, so this is going to be our formula. And we need to put A and B in there. So the answer here is 3 times 7 to the x. Okay? Now, this part, it gives us an x. It tells us we want to use 5. So we say 3 times 7 to the 5th power. And then we need to use our calculator and figure that out. So 3 times 7 to the 5th power would be 5,421. Okay. So when you're doing these problems, you don't need to rewrite this, but you do need to tell me, like, do this. Initial value 3, growth factor 7, f of x equals 3 times 7 to the x, and f of 5 equals 3 times 7 to the 5th equals, I ran out of room, 5,402. Yeah, that. 50,421. That's what that is. Okay? Good. So now we have a decay problem. I can look at this and know that because our b is a fraction less than 1, it means it's going to be decay, which means our graph is going to go down. Okay? So the process is the same thing. So we're going to do 2 times, and just so you know, if you put your fraction in as a decimal, it might be easier on your calculator. If you don't know how to figure out the fraction as a decimal, whoops, I'm okay. I'm losing my mind here, hang on. I'm trying to go as fast so that this video isn't forever long. 2 times 0.25 times 0, to the 0, 2 times 0.25 to the first, 2 times 0.25 to the second. Anyway, so to get the decimal, so to get 1/4 into 0.25, you would do on your calculator 1 divided by 4, and then it gives you the decimal. Okay? So when we do this, we get 32, 2.5 and 0.125. And then we can graph that. So negative 2, 32 isn't going to be on the graph, which is fine. Negative 1, 8, 0, 2, 1.5, so it's halfway, and then 2.125, which is barely, and notice that it's going down, okay? If you know that this fraction means it's dk and will be going down to the right, it's one way to help you know that you've done things correctly, because if you graphed your numbers and it didn't do that, then you did something wrong, okay? And again, what's the y-intercept? It's our starting value, our a. What's the multiplier or common ratio or growth factor? Excuse me. It's our fraction in this case, or our b. Okay, so this example is like the other one. We're not going to find the end time. We're good. Okay, we need to look at our table. Notice that our numbers are going down, so it's dk. Okay, we need to find our initial value. Remember, that's going to be the one where x equals 0. It might not always be in the middle. This is a true thing, radioactivity and stuff, and over time and stuff. So it's a true thing. So you're not going to have negative seconds. So therefore, we start at 0, but that doesn't matter. Our initial value is wherever the x is 0. Our y is our initial value. And our growth factor in this case is going to be a fraction because it's going down. So it's going to be 1 over, what's it going down by? Well, 20 divided by what gives us 10? That would be 2. 10 divided by 2 gives us 5. Or 10 times 1/2 gives us 5. 5 times 1/2 gives us 2.5, etc. So remember, our formula looks like this. So, and this is A and this is B. So we're going to do 20 times 1/2 to the power of x. And we're going to put a 5 in there. I don't know why we chose 5 every time. So 20 times 1/2 to the power of 5 is 0.625. When you do that, remember, it needs to be less than this, right? Because we're going down. So whatever number that is probably going to be higher than 5, right? Higher than 4. And so our number needs to be less because it's going down. That's all I have. Let me know any questions you have on Zoom.